Okay, so yesterday we talked about the segment addition postulate, which is a fancy way of saying what? Segment addition postulate is a fancy way of saying what? I mean, that's part of it. Part of a segment, okay. Yeah, one part plus the other part equals the whole, right? Could it be 3 parts? We didn't look at any, but could it be? Yeah? You just add together all 3 to get the total. Good. What was the difference in the rewind between number 1 and number 2? Urath?
In number 1, it had the midpoint, but in number 2, it didn't.
Okay, so if it's the midpoint, then what do you do with these 2 expressions?
You combine them.
That's not what any of you did. If it's the midpoint, what do you do with those 2 expressions? You didn't add them. Yeah, but what's the equation? Can you say that louder? Yeah, so you don't add them together. What are they? They are equal to each other. So if it's a midpoint, they're equal to each other. You guys all just did that on the rewind, and then you all said something that none of you did on the rewind. So you add them together if it's like number 2, because how is number 2 different? It doesn't tell you it's a midpoint. It gives you a part, and a total. So you add together part plus part and to get the total. Midpoint tends to be a little bit easier because you just know the piece has to equal the piece. Okay, so the 2 pieces are equal. What's going on down here? X is a midpoint, so that means X divides VZ in what? 2. Into 2 equal pieces, right? So if the whole thing is 23.4, how do you find each piece? Just divide by 2. Good, divide by 2. And again, remember, you're always allowed to use a calculator in here, but for things like this, you can probably do that without a calculator, okay? But feel free to check yourself if you need it. Okay, so we're going to talk today about the angle addition postulate, which is exactly the same as the segment addition postulate. A piece of an angle plus a piece of an angle equals the total angle. But before we start, I want to talk about angles. So what is an angle? What is that's how we measure it, right? We measure it in degrees, okay? What does it look like? Can you show me with your hands? Yeah, like this, right? So it looks like this. So an angle is made up of 2 rays with a shared endpoint. So that's one angle, all right? This could also be an angle. How are these different? One's bigger, one's acute, and one's obtuse, right? So we have a lot of different words for angles. We have acute, obtuse. What other kinds of angles do we have? Right angles, and does anyone know the other one? Luis? A line, a straight line. Yeah, a straight line is technically an angle, okay? All right, how do we name angles? This is really important. So when we name angles, we have to use 3 letters. So it's like a plane in that you use 3 letters. Okay, but the symbol in front is like this. So it's angle, and then this angle would be angle ABC. Or I could call it angle CBA. That's it though. Those are my only 2 options. What do they have in common? The same letters, okay, and then what else about those letters? They're in what kind of order? The order that it's written in? Okay, which one has to be Urath?
B has to be in the middle.
B has to be in the middle because it's the vertex. Vertex. So the corner of an angle is called the vertex. So when you're naming an angle, that letter has to be in the middle. So you have to read it in order like A, B, C. All right, so what are the 2 options for this one? Angle QRS or angle SRQ. Sometimes you will see it named as just angle R, which is okay. You can just use 1 letter. What letter does it have to be, though? The vertex. And that does not work if it's like this. Why can't I just call it R if it's like this? Because there's other angles there, right? So R could be this one, R could be this one, or R could be the whole thing. Okay, so QRS would be the whole thing. What's this one called then? PRS. And what's this one called? QRP. Okay, so QRP would be this one right here. Basically, when I draw it, if I draw it like that, just name the letters in that order. What do you think the difference is between the interior of an angle and the exterior of an angle? What's interior mean? Inside. So interior of an angle would be all this space. So what would be exterior? The outside, just the outside of an angle. All right? That's not something you really are going to use a lot. Just keep in mind what interior, exterior means. Okay, and so at the very beginning when I said what's an angle, Guillermo, you said degrees. What did you mean by that? That's how you measure it, right? So we measure every angle in degrees. And what's the tool that we use to measure an angle? Does anyone know what this is called? A protractor, right? We're not going to actually measure any angles or use any protractors. Have you guys done that? Did you do that in middle school? Maybe sometimes. Have you seen a protractor before? All right, so this is a protractor. I do want to say a couple things about it though. So why does it have 2 numbers at every spot? Why does it have 2 numbers at every spot? So why do I have a 0 and a 180, a 10 and a 170, a 20 and a 160? Because take a look at this red angle right here. If I measure it, how many degrees is that? 120. How do I know it's not 60? Because it crosses both of those numbers. How do I know this one is 120? Maybe. How do I know this isn't a 60-degree angle? Martin? Okay, so the 0 is where it starts, and it's starting on the inside here, so that's the number that I follow. So it ends up here at 120. If the angle had gone this way, stop moving, protractor. All right, if the angle, nope, if the angle had gone this way, like this, there we go. All right, if it had been this angle, it would have been 60 because where's the 0 here, on the inside or the outside? On the outside, so I follow the outside numbers. The reason they have 2 sets of numbers is so that you can use the protractor no matter which way your angle opens. So if it opens from the left to right or the right to left, okay? You also know, even just looking at this red angle that we originally looked at, does it look acute or obtuse? Obtuse, it looks bigger, right? So it's going to be the bigger one. All right, so let's define what that means. Acute is like a little angle, but more specifically, how many degrees can an acute angle be? Because I don't want to just say like a little angle. It could be 45. It could be less than what? 90. Nope, a little higher than that. Less than 90. Very good. So less than 90 degrees. So an acute angle is less than 90. I always remember it because it's cute and little. All right? So little angles are cute. It's acute. Obtuse means what? More than 90. Very good. More than 90. But it has to be less than what? Good. Somebody said it. Say it louder. Good. Less than 180. A right angle is what? 90. Exactly 90. Does anybody know the symbol that we use? Yeah, there's like a little square in the corner. If it's a right angle, there's a little square in the corner. If I don't tell you it's a right angle, or if I don't put that square, can you assume it's a right angle? No. Do not assume in geometry, okay? Even if the picture, even if you're like, I swear that looks like a right angle, if there's no square there, don't assume that it's 90, okay? So this one's exactly 90 degrees. And then what about a straight angle? A line. It's exactly 180 degrees. All right, so it makes a straight line. This also looks like, what did we talk about yesterday and the day before that this looks like? Opposite rays. Very good. So a ray, opposite rays, a line, and a straight angle all look very similar, and they would all be 180 degrees. Okay, remember the vertex is always at the corner or where it meets. So this is still the vertex, even though it's on a straight line. Okay, so this practice should be pretty simple. All you're doing is classifying it as obtuse, acute, right, or straight. So at your boards, A, B, C, D, E, F, and G. Please note this little guy in E. All right, go. Okay, so if we had the segment addition postulate, which meant part plus part equaled whole, the angle addition postulate also means part plus part equals whole. Instead of talking about segments, we're just talking about angles. So for instance, does everybody, when you're looking at this picture, can everybody see that there are 3 angles here?
Yes.
Where are they? Or name them for me. What are they? RQS, SQP, and RQP. So all of them have Q in the middle because Q is the vertex of all of them. Which 2 add up to which other one? So which RQS, SQP add up to RQP. Perfect. So RQS or PQS and SQR add up to the whole. So part plus part equals whole. So if I tell you that this is 40 and this is 70, what could you do to find RQP? Add them together. How do you know you add here? Yeah, you're finding the total. Okay, what if I told you this? What if I told you RQS equals 20 and RQP equals 110? So what information have I given you here?
You have given us the total.
Okay, so RQS, which is 20, and then also the total. So this whole thing, I don't know how else to label it besides that. So that whole thing is 110. So then what would you do? Subtract. So when do you subtract? Whenever they give you the whole thing. Okay, so if I give you 2 parts, you add. If I give you 1 part and the total, you subtract. And that's the angle addition postulate. Just like yesterday, the angle addition postulate and the segment addition postulate are just fancy ways of saying stuff you guys already know. Part plus a part equals the whole. All right, if you have 2 parts, add them. If you have 1 part and a total, subtract them. Can somebody remind me what the word bisect means?
To cut.
Cut how? Directly into 2. Are the pieces, they're the same. So to cut into 2 equal pieces. Okay, so if I said that this is 110 and QS bisects it, how could you figure out each of these? Divide by 2. Very good. So you could divide by 2. All right? What would you do here if I told you QS bisects? If I said QS bisects, how would you solve for x? Did you say something? 8x equals? Good. How do you know that? You're right. So Micah's right. Micah said 8x equals 5x plus 18. How do you know that they're equal?
Because you're trying to find the
What word did I say that lets you know that they're equal? Bisect. Just like if you heard midpoint, you knew that they were equal. If you hear that QS is a bisector, that means these 2 things have to be equal to each other. So you can say 8x is equal to 5x plus 18. So what would I do then to simplify this? Subtract 5x minus 5x, and that's going to give me equals 18, so 6. Good. X equals 6. So now I'm going to plug that into which one?
The 8.
Good. This one would give me what? 48. And if this is 48, what's this?
48.
Good. So then all together that would be 96. All right, so again, what's that key word that tells you they're equal? Bisect. Okay, if you have a part and a part and you need the total, you'd add them together, but if it says bisect, that means you can set them equal to each other. If ABD is 124, find the measure of CBD. So if ABD is 124, do you have two parts, or do you have a part and a total?
A part.
So what are we going to do here? Subtract. So I'm going to do 124 minus 68, which is 56 degrees. If ABD is 176, if ABD is 176, how can you find the measure of CBD? Okay, how do you know that? Yeah, you see a little square. So even though there's no number, this tells you that this is 90 degrees. And since I gave you the total 176, I'm going to subtract 176 minus 90. And when I subtract that, oh, I don't know why I just borrowed there. I end up with 86. Good. Okay, so I would like you to try, hang on before you get up, I would like you to do the top four, and then I would like you to do one of the ones on the bottom. So one of the three on the bottom. I would recommend, no, I don't care. Pick any one you want. Okay, so the first four and then the one on the bottom.